জানতো সোয়াদুটো থেকে তো ক্লাস তোমাকে আমি অনেকক্ষণ আগে পাঠিয়ে দিয়েছি, তুমি দেখোই নি বলে। একটা বাচ্চা আসেনি, আমি বসে রয়েছি।
Powering on.
Yeah, Riya?
Connected.
Riya?
यस सर।
हाँ, क्या हुआ था बेटा लास्ट दिन?
सर लास्ट डे सर वो पढ़ रहे थे, एग्जाम था ना।
क्या था कल था एग्जाम?
हाँ
कौन सा एग्जाम था बेटा?
सर केमिस्ट्री था।
कैसी हुआ बेटा?
अच्छा था सर।
It was good.
सर सिर्फ एक सम्स में थोड़ा या
वेरी गुड। तो क्या क्या दिया था?
क्या क्या दिया था सर, ये केमिकल बॉन्डिंग वगैरह से दिया था, थोड़ा बहुत थोड़ा उससे ज्यादा दिया हुआ था।
क्या क्या आया था केमिकल बॉन्डिंग से?
इलेक्ट्रॉनिक, एक मिनट से बता रही हूँ। ये इलेक्ट्रॉनिक कॉन्फ़िगरेशन वगैरह आया, तो बस एक हमको सम्स में थोड़ा प्रॉब्लम हुआ था। बोर्ड्स मॉडल से कोई ऐसा कोई सम्स था उसमें वो कर पाया, वो मेरे से हुआ नहीं, और सब करेक्ट किए थे।
नंबर आ गया?
डेफिनेशंस वगैरह थे सारे, तो हो गया।
नंबर आ गया?
नहीं अभी नहीं आया है। नहीं नहीं
ये ऑनलाइन एग्जाम नहीं हुआ?
ऑनलाइन ही हुआ है।
ऑब्जेक्टिव था पूरा?
नहीं
पूरा
सर।
रिया श्रीवास्तव, उसको एक बार भेज दो। उनको मोबाइल नंबर है आपके पास? अंजलि, रिया
हाँ
श्रीवास्तव, उसके पास?
सर। सर
सिद्धार्थ
रिया
वाला?
शायद क्लास नहीं करेगी, उसका तबीयत नहीं ठीक है, उसको फीवर हो रहा है ना।
अच्छा, अंजलि को भेज दो एक बार। अंजलि को है आपके पास फोन नंबर?
नहीं सर।
क्या छोड़। सिद्धार्थ, काइंडली सेंड इट टू प्रियांशु।
सर आज उसका एग्जाम है, वो नहीं आएगा आज।
अच्छा, और एक पहले और एक बाकी है। क्या एग्जाम है उनका आज? सिद्धार्थ, क्या एग्जाम है उनका?
यस सर।
सिद्धार्थ, उनका क्या एग्जाम है आज?
सर स्कूल का है कोई उसका।
ठीक, अंजलि को आने दो। तो अंजलि भी आ गई, एक सेकंड। चलो, what we are going to do today, what we are going to do today is we are going to start a new chapter called as gas laws. मेरा 4 चैप्टर मेरा खत्म कर दी मैंने. So we have finished 4 chapters. So what we are going to do today is we are going to start a new chapter called as gas laws. स्कूल में हो गया सिद्धार्थ? स्कूल में हो गया बेटा? समझ में कुछ आया? Did you understand
Yes,
anything?
sir.
Huh? Siddharth, did you understand anything? रिया, गैस लॉस हो गया स्कूल में?
हाँ सर।
समझ में आया सब कुछ?
सर थोड़ा बहुत, मतलब मैंने स्टार्टिंग क्लासेस नहीं किया था ना, तो इसलिए पता नहीं है कुछ खास।
फिर स्टार्टिंग क्लास में कहाँ पर थे आप?
कहीं नहीं सर, घर पे थे, नहीं किए थे क्लास।
क्यों? अंजलि, स्कूल में हो गया गैस लॉस बेटा?
नो सर, अभी तक नहीं हुआ है।
We are going to start with gas loss. Now, there are three states actually. One is solid state, one is liquid state, and the other one is gaseous state. So these are the three states that we have. Now, solid state is essentially belongs to class 12. लिक्विड स्टेट्स को बारे थोड़ी बहुत हम लोग इसी चैप्टर के साथ पढ़ेंगे. सो क्लास 11 में ही है थोड़ा सा सरफेस टेंशन एंड विस्कोसिटी, और कुछ है नहीं. सो क्लास 11 में थोड़ा कुछ है. गैसियस स्टेट को बारे में वी हैव टू डू इन डिटेल्स. वी हैव टू डू इन डिटेल्स. कहां चला गया अंजलि? बाकी दो अंजलि.
सर पता नहीं।
रिया श्रीवास्तव को क्या हो गया रे बेटा? अंजलि,
हाँ सर।
रिया श्रीवास्तव रिया श्रीवास्तव को क्या हो गया?
सर उसको बोले मतलब कि आज क्लास करेगी या नहीं, मतलब कुछ रिप्लाई नहीं आया सर, व्हाट्सएप किए थे।
कभी की थी? कभी किया था?
हाँ सर, थोड़ा देर पहले किए थे।
बाकी दोनों को आने दो, एक सेकंड रुको. दोनों कहाँ चला गया देखते हैं. सिद्धार्थ को आने दो. सिद्धार्थ को आने से मुझे कोई आवाज देना. अंजलि,
ओके सर।
सर आ जाओ. सिद्धार्थ आ गया, मुझे कोई आवाज देना.
रिया नहीं आएगी?
नहीं,
एग्जाम चल रहा है उसका।
हाँ उसको एक्चुअली फीवर है, इसलिए वो नहीं कर रही है क्लास।
ओ मतलब तुम लोग एग्जाम खत्म हो गया ना?
नहीं।
ओ अभी है।
हाँ
अच्छा।
चलो सिद्धार्थ जब आएगा आएगा. चलो दोनों को साथ स्टार्ट कर. सो गैस लॉस के बारे में हम लोग का डिटेल्स करना है. ठीक है. तो गैस लॉस को बारे में आई हैव गॉट एसेंशियली थ्री डिस्टिंक्ट डिविजन्स. एक होता है आइडियल गैस. इसमें जो होता है, इसमें जो सेकंड डिविजन्स होता है, सेकंड जो क्लासिफिकेशन होता है, दैट इज एसेंशियली व्हाट वी कॉल एज रियल गैसेस. जो रियल गैस को हम लोग ये भी बोलते हैं वैन डर वाल्स गैसेस. और थर्ड एक चीज है जिसको हम लोग बोलते हैं लिक्विफैक्शन ऑफ गैसेस। और आइडियल गैस को जब डिटेल्स में जाएंगे, सो देयर आर टू मोर थिंग्स एक्चुअली, द काइनेटिक थ्योरी ऑफ गैसेस। So this is the chapter overview of the gaseous state. So you have to remember this chapter overview. पहले क्या है, it makes actually studying simple. हम लोग आइडियल गैस जाएंगे। आइडियल गैस को बारे में when we talk about ideal gas, essentially we talk about 3 laws or 4 laws. One is Boyles law. Second one is Charles law. The third one is Avogadro's law. And the fourth one is called what is called as Gay-Lussac's law. So these are the 4 laws. 1, 2, 3, 4. And combining all these laws, we get essentially the gas laws, combined gas laws. I'm giving you an idea about what are the things you can expect in this chapter. So when we talk about the first thing, ideal gas laws, then ideal gas laws ko bare mein we are going to look into the Boyle's law, Charles' law, Avogadro's law, and the Gay-Lussac's law, which is also called as the Hamilton's law. These are all experimental observations, right? But we need, in order to understand these experimental results, why this happens, we basically looks into kinetic theory of gases. So this entire thing encompasses the first part. The second part essentially goes into this part, the real gases, or what we call as the van der Waals gases. And the third part essentially talk about liquefaction of gases. So there are essentially 3 parts. So this is approximately going to take 2 lectures. This is going to take around 1 lecture. This is going to take around 1 lecture, and plus 1 additional lecture you will be requiring for discussion of some general concepts which we are going to do today. So approximately you are going to take 2.5 weeks to complete this entire course, this entire gas laws. Then of course we are going to move into thermodynamics. Chalo, let's start with gas laws first. Now we talked about dipole moment in the last class. We talked about dipole moments in the last class, and we are going to use those concepts today. We are going to use these concepts today. Right. Now, out here, the gases can be of different types. What are the types? Say, for example, I may have H2 or N2. Say, for example, like this, dihomoatomic gases. This kind of gases, we call them as to be non-polar. Then we may have, say, for example, HCl gas or carbon monoxide gas. These gases are called as polar gases. Right? So essentially, we have got these 2 different kinds of gases in the system. Non-polar means essentially, what does it mean? It means that it has dipole moment is equal to 0. We talked about dipole moment in the last class. Do you remember Anjali and Siddharth? Ria didn't do the last class. The
Yes,
dipole
sir.
moment. Right. So in this non-polar gases, mu is equal to 0. As far as polar gases are concerned, for this, mu is not equal to 0. That means out here, there will be no vectors operating out here. But out here, there will be a vector operating out here. Now, what we are going to do next is this, that we are going to study about the interaction. We are going to talk about the interaction between molecules of a gas. Right. So first thing, say for example, I have got a non-polar gas. Say for example, I have got a non-polar gaseous system. So I am having what? I am having a non-polar gaseous system. Say for example, it can be H2 or N2. That means it has got no dipole moment. What it means is like this, that I have got, say for example, one molecule out here, The second molecule is out here. I've got two molecules out here, right? Now, it has got no permanent dipole moment. That means it has got, let me write it down out here, no permanent dipole moment. Out here, I've got no permanent dipole moment, right? Now, what I have in these atoms? In these atoms, I have got a plus charge out here and the plus charge out here. That means this is the nucleus of these two atoms. And the electrons are rotating around this particular nucleuses. At one point at time, what happens is like this, that there will be a distortion of this particular atoms of the electronic clouds. Distortion of the electronic clouds of, say, for example, this is my atom A. Suppose this is my atom A and this is my atom B. Atom B. Now, at one point of time, suddenly there will be a distortion of electronic cloud. Distortion of electronic cloud. That means the curve is now whenever there's a distortion, how will this basically this look like? It will basically look like this. That means the minus charge, the electron cloud has moved to the right. My nucleus still stays at out here. There is more electron density at this particular area. So this essentially becomes what we can say is delta minus. This becomes essentially delta minus. And this side becomes delta plus. Now, whenever this side becomes delta negative and comes in contact with the atom B. So atom B also has got electronic clouds out here, electrons out here. So this higher electron density is going to basically repel this particular electron density and send it out in this particular direction. So a majority of a certain amount of electron density is going to move from here to this side. That means the structure in this case is going to look like this. It's going to look like this, that I have got. The structure is going to look like this. Just a moment. The structure is going to look like this. So out here, what happens? Out here, it becomes plus. This particular thing becomes plus, and this becomes minus. So you see that out here, I've got a minus charge, and out here, I have got a plus charge. So there will be a transient form of attraction, between this minus charge and this plus charge. So there will be transient attraction. What do you mean by transient attraction? Transient attraction actually means that this distortion of electronic clouds is temporary. The next moment, what might happen is this: the electron cloud, instead of going in this direction, will move in this direction. Then this side will become plus, and then this side of the electron will be negative. So this is a transient, means temporary kind of an attraction is going to take place. And this temporary kind of attraction sometimes, so this it operates between this, sometimes it repels, sometimes it attracts. So this is a transient kind of attraction. And we call this kind of an attraction, we refer to this kind of an attraction, we refer to this kind of an attraction as the London forces of attraction. We call this as the London forces of attraction. So even though hydrogen and nitrogen do not have any dipoles within it, however, they are associated or they are attracted towards each other through this transient attraction. And this transient attraction is called as the London force of attraction, and its attraction nature, this force of attraction is inversely proportional to 1 by r to the power 6. What do you mean by r1 to the power r to the 6? That means the distance between this and this is, suppose this distance is r, then this attraction will be 1 into r to the power 6. That means it's a very short. That means क्या बोलता है? When the distance between this r is very small, then only then the force of attraction is considerably higher. Because r is inversely proportional to the r to the power 6. तो r जितना छोटा होगा, force of attraction उतना बड़ा होगा. So when it comes very close, the force of attraction will be there. If r increases, then it diminishes by 1 to the power 6. That means it operates only in close range. So this is a very close range force that we are talking about. So what kind of attraction at the end of the day you have? You have got essentially transient dipole attraction. Because this electronic cloud shifting is very fluctuating. कभी इस साइड आता है इलेक्ट्रॉन क्लाउड, कभी इस साइड चला जाता है, कभी इस साइड आता है. So it moves on like this. So जब इस साइड में इलेक्ट्रॉन आ जाएंगे, so this becomes minus, this becomes plus, and an attraction develops. Next moment it comes back to original configuration like this. There's no attraction at all. The next moment what happens is the electron goes in this particular direction. Then the side of attraction, then the attraction distance or the dipole moment direction changes. So it's a transient attraction, right? Transient dipole attraction, and this kind of force is called as London force of attraction. So what kind of systems undergoes this kind of transient dipole attraction? Essentially, it takes place between non-polar gaseous system. Is it clear to three of you? Anjali, Ria, Siddharth?
Yes.
Ria Shaw, Anjali?
Yes, sir.
So this was for non-polar gaseous system. Now say for example, I have got a non-polar gaseous system and a polar gaseous system. So I have got a mixture of gases in which one of the molecule is non-polar, the other one is polar. Right? Very good. Let me now draw. Suppose this is my non-polar gaseous system. That means out here, the nucleus is at the center. The nucleus is at the center. And the electrons are distributed evenly in a spherical system across this particular nucleus. And then I have got a polar gaseous system. I have got a polar gaseous system means, say for example, I have got a polar gaseous system means this is my polar gaseous system. Right? Now, if say for example, polar means it has got a dipole moment. Polar means essentially what? Polar means essentially the dipole moment is not equal to 0. Suppose now the dipole moment direction for this particular gaseous system is this. So suppose that it is this. The dipole moment is in this particular direction. So I have got a dipole moment in this particular direction. The dipole moment direction, you remember, it goes from, suppose this is A, this is B. If this is, say, for example, minus, delta minus, if A is delta plus, then my polar direction, the dipole moment direction is this. That means the head points out towards the negative charge. So if the dipolar direction is in this particular direction, it means my electron density in this particular atom will be higher out here. So the minus charge will be out here. So minus charge will be out here. Now, when this minus charge is out here and it comes in close proximity with this non-polar molecule, mind it, this is a non-polar molecule. This was my non-polar molecule. So when this minus charge comes in close proximity with this is the electron density, higher electron density, negative charges in this particular area. So what is going to do is this, this area electrons is going to get repelled and move in this particular direction. That means under these circumstances, what is going to happen? Under these circumstances, what is going to happen is this molecule will now get distorted. That means right now, under this condition, what happens is this, the minus electrons moves in this particular direction. So there will be a higher minus charge out here, and out here, the plus charge out here. So what you are doing is this, that this polar molecule, this is a polar molecule, is inducing a dipole in this case, in this other molecule. This was my non-polar molecule A. This was my polar molecule B. Now this was a dipole moment, and this dipole moment is inducing a dipole in this non-polar system. So this kind of interaction, you call it as induced dipole interaction. That means out here, this is my induced dipole in this, and this is my dipole, permanent dipole. So what kind of interaction is taking place? Induced dipole and dipole. Now this is minus this has become plus. So naturally it means there will be attraction between them. So once again, this is a nothing but an attractive force. And this attractive force is the reason is between them is induced dipole interaction. Right? Now this also out here, this force of attraction is also a function of r to the power 6. That means this also is essentially a short range force. What do you mean by short range force of attraction? By short range force of attraction, it is meant that this kind of attraction is only going to operate when the molecules are very close to each other. This one also is a short range interaction, right? This one also is a very short range interaction, close range force. So this force and this force, both of them are going to actually operate only when the molecules are very close to each other. So this was permanent dipole, induced dipole interaction. Anjali, Riya, Siddharth, clear or no?
Yes, sir.
Yes, sir.
Anjali?
Yes, sir.
सिद्धार्थ तेरा नेट को क्या हो रहा है बेटा?
सर आज जो थोड़ी ज्यादा प्रॉब्लम हो रही है उसमें।
लग रहा है मुझे।
सर वो वाला नोट्स फिर से दिखाइए ना प्लीज।
हो गया बेटा?
हाँ सर।
Next one is the third kind of interaction. So हम लोग अभी तक कितना किया? Now number one was this. My number one of interaction was this. This was one number 1 point. The second kind of interaction was this. Non-polar gaseous system and polar gaseous system, right? So induced dipole interaction. The third one we are talking right now is between permanent dipole interaction. So out here, it is permanent dipole interaction. So it is a permanent dipole interaction. Now what happens out here is very simple. This is the simplest to understand. What happens is this. Suppose I have got a particular molecule like this. Suppose I have got a particular molecule like this. And I have got another particular molecule like this. I've got two molecules. And both these molecules, in both these two molecules, mu is not equal to 0. That means both of them have got a dipole. Right? Now what happens is this. Suppose the dipole in this case operates in this particular direction. Similarly, the dipoles, since both of them are the same molecules, the dipole is going to operate in this particular direction. That means in this case, this is minus. and this was plus. In this case, this is plus, and this is minus. So when the dipoles are aligned in this way, there will be an attraction between this. The minus and the plus is going to attract. So there will be a force of attraction once again. So all these three forces that we talked till now, force of attraction. Now this force of attraction takes place what? This force of attraction takes place due to permanent dipole attraction. And how does this force vary? This force of attraction varies as, once again, inversely proportional to R, but raised to the power 4. That means this is not so shorter range. Previously, it was very short range, R to the power 6. This was also R to the power 6. But in this case, it is R to the power 4. That means it operates a greater distance between molecules than the induced dipole permanent dipole interaction and the induced dipole reaction. So these three forces, that means right now what we did was this, we talked about three forces. Number one, induced dipole attraction. Number two, induced dipole permanent dipole attraction. And the third thing was permanent dipole attraction. Together, these three essentially constitutes, all of them are attraction, by the way. So together, these three constitute what we call as van der Waals force of attraction. That means what? All gaseous molecules are attracted towards each other. Right. Now, this will be having important consequences when we talk in terms of liquefaction of gases. That's the last part of the discussion, liquefaction of gases. This particular, all gaseous molecules are attracted towards each other. That is, there's a force of attraction operating between the molecules. This will be important for liquefaction of gases when we go into the final part of our discussion, that is liquefaction of gases. Even for this also, we'll see that it will have consequences. But as far as ideal gas laws are concerned, right, we say there is no attraction between molecules. That we are going to understand a little bit later. Now, kindly see your books and see whether you have understood or not. We are going to move into the second part, right? Second part means we are going to talk about the variables in a gaseous system. It has got only 4 variables: pressure, temperature, number of moles, and volume. We are going to understand their units today. It will be completely a general discussions, but without completing this discussion, you cannot move on into the Boyles law, Charleston, all those things. So kindly look into your books about these three topics: van der Waals force of attraction. Any book, it may be Chaya Prakashani, it may be a Nutan's book, you may be CBSC book, or whatever book you follow. Kindly see through it and see whether you've understood or not. I'm just coming. 1 minute. Is it clear to all of you? Is it clear, better? Anjali,
Yes, sir.
Priya?
Yes, sir.
Chalo. Next we move. So now what we are going to go is, we are going to go into some experimental observation. An experimental observation essentially has got 4 laws incorporated into it. One of them is called as the Boyles law. That means out here PV relationship. At constant temperature. Second one is Charles' law. Out here, volume temperature relationship. At constant pressure. Third one, Gay-Lussac's law. Means out here, we are going to talk about pressure temperature relationship. At constant volume. And fourth one is Avogadro's law, which essentially talks about volume with number of moles. At constant pressure and temperature. So these are all these laws, you have to remember this, are nothing but experimental observations. These laws do not have got any theoretical proof. In order to explain these 4 laws, we have devised a particular theory, which is called kinetic theory of gases. Which you call as a kinetic theory of gases. But this will come later. All you need to understand is this. These are all experimental observations. Right? Now, if you look at these experimental observations, first one is how many parameters you have got? Pressure and volume relationship. That means pressure, how is pressure changing with volume? At constant temperature and number of moles, constant mass, constant amount, not mass, constant amount. That means I have got 4 parameters: pressure, volume, temperature, and number of moles. If you look at Charles' law, it is volume versus temperature at constant pressure and number of moles. Then once again, there are only 4 parameters. Out here, pressure was there, volume was there, temperature was there, number of moles out here. Out here, volume and temperature was there at constant pressure and number of moles. If you look at the gas laws, this is pressure and temperature when volume and number of moles are constant. If you look at Avogadro's law, it is volume with the number of moles when pressure and temperature are constant. That means what we can say is this, that this particular chapter deals with only 4 variables, only 4 parameters. One of them is pressure. Second one is volume. Third one is temperature. And the fourth one is amount. Amount means number of moles. These are the only 4 things that we need to define. These are the 4 different parameters. based upon which all these 4 laws are dependent upon. So the first thing comes first. We need to understand the units of all these quantities. We need to understand the units of these quantities. Now, as far as the fourth is concerned, कुछ है ही नहीं इसमें. Essentially, this is number of moles. So we basically talk about number of moles. And number of moles, you know, essentially what? Essentially, it is the weight divided by the molecular weight. So it has got no dimension. It just gives you the quantity. That means this essentially just give you the amount or the quantity. Let me put the amount. Let me write down amount. So it just gives you the amount. Number of moles. So this one is done. We need to understand this 3. Right? Now this temperature, let me do this first. At the moment, you'll understand this later when we talk about Charles' law. It essentially degree centigrade. Or sometimes it is expressed in terms of Kelvin. Kelvin is nothing but equal to degree centigrade plus 273. Now, why does this 273 comes? That we'll understand when we talk about Charles' law. Right now, we are talking about what? Units of all these parameters. We are talking about this. So, amount is given by number of moles. कुछ है ही नहीं उसमें. Temperature is given as degree centigrade, but throughout gaseous system, we use this particular scale in Kelvin. Kelvin is given as degree centigrade plus 273. The remaining is pressure and volume. These are the 2 units that you need to understand in some details. बाकी दोनों तो बराबर, simple. चलो, let's talk about volume. So what we are going to discuss about is units of volume. Right. Now what I'm going to do is this. I know meter, the decimal system, meter, decimeter, centimeter, millimeter. This up to this much will do. Right? That means meter. No. So meter to decimeter essentially is what? 10 to the power. If I want to convert meter into decimeter, all I need to do is multiply by 10. If I need to convert meter into centimeter, all I need to do is multiply by 100. If I need to convert meter into millimeter, all I need to do is convert it by 1000. Similarly, opposite, if I need to convert millimeter into meter, I need to divide it by 1000. Similar. It's basically nothing but the decimal system I am talking about. Right. Now, volume. Volume means what? Volume can be given as meter cube. Meter cube means what? Meter into meter into meter. Right? That means, say, for example, I have got a cube like this. I have got a cube like this. Then this is, say, for example, 1 meter. This is 1 meter. And this is 1 meter. Then the volume of this particular cube is called as 1 meter cube. Right? So if I need to convert meter cube into, say, for example, centimeter cube, right? All I need to do is I need to convert essentially meter into centimeter cube. I need to convert meter into centimeter cube. So what I'm going to write? So meter into meter into meter. So meter to centimeter is 100. So I can write this as 10 to the power 2 centimeter into 10 to the power 2 centimeter into 10 to the power 2 centimeter. That means 1 meter cube is equal to 10 to the power 6 centimeter cube. Simple. Clear? Is it clear? Anjali, Riya, Siddharth?
Yes, sir. Yes, sir.
Siddharth?
Yes, sir.
Right. Now, there's some alternative units for this. Volume units, special. These are special units. You know this unit. You have heard this name in units. You have seen your father talking about it when he basically goes to either fill up his scooter or car, whatever it is called as liter. Right. What is 1 liter? 1 liter is nothing but 10 to the power 1000 centimeter. 1 liter is nothing but 1000 centimeter cube. Now, if I want to convert it into meter, what I'm going to do? Meter cube, if I want to convert this into meter cube. So I can write down out here is 1000 into centimeter, into centimeter, into centimeter. And then I'm going to write down 1 centimeter is equal to 10 to the power minus 2 meter cube. Minus 10 to the power minus 2 meter. So I am going to write 10 to the power 3. This is 1000 is 10 to the power 3 into 10 to the power minus 2 meter into 10 to the power minus 2 meter into 10 to the power minus 2 meter. That means is equal to 10 to the power 3 into 10 to the power minus 6 meter cube, which means 10 to the power minus 3 meter cube. That means what I'm going to say is this: 1 liter is equal to 1000 centimeter cube. 1000 centimeter cube is equal to 10 to the power minus 3 meter cube. This is one conversion that we'll be requiring again and again. Right? Similarly, if I write down 1 milliliter, 1 milliliter means what? If you look out here, milliliter means essentially, say for this one, that means I need to divide it by 1000. So 1 milliliter is equal to 1. I'm dividing this 1 milliliter means I need to divide it by 1000. This is liter, this is deciliter, this is centiliter, this is milliliter. That means liter, deciliter, centiliter, milliliter. So I need to divide it by 1000. So 1 milliliter is equal to what? 1 milliliter is equal to 1 centimeter cube. This is the second thing that you need to understand. So the units of volume is given by number 1, meter cube or centimeter cube or milliliter cube or millimeter cube or decimeter cube. But those things are not usually in use except in certain problems. We use liters. Whenever your father goes to basically go and get his the fuel, he talks in terms of liters. Aaj 1 liter bhara hai, 2 liter bhara hai. He never talks in terms of millimeter cube or centimeter cube. But in problems, we require those things. So the most common unit of volume is in liters. And I've given you the conversion of liters into centimeter cube and millimeter cube and meter cube. I can do also millimeter cube, but that is not something which we require. Right. So this was the units of volume. I'm just writing this in a very short way. Kisi book mein itna sundar, they don't explain it like this way, but these are all very much required for your problems. Have you written it down or you're still writing it down? Likh liya beta? Yes or no? Riya Shah, Anjali?
Yes, sir. Yes, sir.
Right. Then comes unit of pressure. Then we talk about units of pressure. Right. Now, first of all, what is pressure? Pressure is nothing but force per unit area. So pressure is nothing but force per unit area. Now, in MK's SI system, force is given as newtons, that is capital N, and A is given in terms of meter square. So when pressure is, while defining pressure or talking about the units of pressure, when there is 1 Newton of force in 1 unit area, that is Newton per meter square, you call this to be 1 Pascal. So what is Pascal? It is 1 Newton of force per unit area. And what is the direction of this particular force? By the way, The direction, suppose this is my unit area. Suppose this is my unit area. Suppose this is my unit area. Then the force has to act perpendicular. Is the perpendicular force per unit area. That is how we define pressure. So it is the force, the perpendicular force per unit area is called as pressure. And when the force is expressed in Newton and the area in meter square, then the unit we get is called as Pascal. But Pascal is a very small quantity. Very small quantity. So all you need to do is this. You have to make it a bigger unit. Then we come in defining bar. So we define 1 bar. What is 1 bar? 1 bar is nothing but 10 to the power 5 Pascal. Means I can write it out as 1,000, 100 into 1,000 Pascal. I can write this 10 to the power 5, 100 into 1,000. Now this one is nothing but kilo. So I can write down out here is 100 kilo Pascal. Clear? So 1 bar is given by 100 kilopascal. We also express pressure in terms of atmosphere. So 1 atmosphere, which we write in short ATM. So 1 atmosphere is equal to 1.01325 bar. So atmosphere is bigger than that of bar, because 1 atmosphere is equal to 1.01325 bar, right? Or you can simply write this in this way. 1 bar is then 10 to the power 5 Pascal. So you can write this as 1.01325 into 10 to the power 5, right? Into 10 to the power 5. So 1 Pascal. So 1 bar you have written down as 10 to the power 5 Pascal into 10 to the power 5 Pascal. That means you can simply write it down as 1, 2, 3, 4, 5. That means 1.01325 Pascal. Clear? So you have converted atmosphere into bar into pascals. Now there are two further units. Pressure is also expressed in centimeter. Also expressed in centimeter. So how do you define it? We have seen that 76 centimeter is equal to 1 atmosphere. This can be shown that 1 atmosphere is equal to 76 centimeter. That means 76 centimeter is equal to 760 millimeter is equal to 1 atmosphere is equal to 1.01325 bar is equal to 1.01325 1.01325 Pascal. Clear? Write this all these units. Try to memorize it. 1 minute में आ रहा है मैंने. All these units will be required while problem solving. Chalo, let's do now. Up to this much, everything is clear. Riya Srivastav, Riya Shaw, Riya Anjali, and Siddharth. You have written down clear neatly in your notebooks.
Yes, sir.
Yes, sir.
That better? Siddharth? Chalo. Siddharth, I think is facing problems with computer.
Yes,
Yeah.
sir.
So right now, we have done what? We have mentioned all the units. Or as I told you, these are depending upon all the 4 parameters. We have told you that it depends upon all the 4 parameters. What are those 4 parameters? Pressure units, we know. Volume units, we know. Temperature units, we know. Amount in moles, we know. Right now, the stage is set where we can at least today discuss about Boyle's law. Chalo. Now, as I told you, all these 4 laws I'm writing down in bold. These are all basically experimental observation. So don't ask for proofs. These are all experimental observations. To explain this thing, we come across what I have told you. We come across what we call as the kinetic theory of gas. But वो तो बाद में आएंगे. First of all, we today and in the next day, we are going to just investigate these 4 laws. Right? Chalo, let's do it. First, let us talk about Boyle's law. What does Boyle's law says? Now, Boyle's law says that pressure of a gas is inversely proportional to 1 by volume. P is pressure and V is volume. When temperature and number of moles, this amount is constant. This is my Boyle's law. Pressure is inversely proportional to 1 by V. Right? That means I can simply write down that pressure, since it is proportional, I can write down there will be a proportionality constant when I write down equal to. So K by V, where K is a constant, is a proportionality constant. Right? Or simply I can write down that PV is equal to constant. That means what I'm trying to say is this: the product of pressure and volume is constant, provided, of course, T and N is constant. Now, suppose I have got 2 systems. I've got the same system. In first system, I have got, say, for example, this is my volume of the system, and the pressure operating on this system, say, for example, is P1, and the volume of the system is V1. Now I am increasing the pressure. Now, what does it mean? If I increase the pressure, the volume has to decrease. Is inversely proportional. If the volume is decreasing, the pressure has to increase. If the volume is decreasing, the pressure has to increase. If the volume is increasing, the pressure has to decrease. Inversely, एक बड़ा होगा तो एक छोटा हो जाएगा. Inversely proportional. That means if I now increase the pressure, to say, then the volume is going to decrease. Suppose this volume is V2. And this pressure is P2. Then just because PV is equal to constant means what? P1, if I look into this particular expression, I can write it down out here. P1 V1 is equal to constant. For this, I can write down P2 V2 is equal to constant. These two are the same constants, so I can simply write down P1 V1 is equal to P2 V2. This is the other expression for Boyle's law. provided of course when temperature and number of moles are same. Clear? Yes or no?
Yes, sir.
Riyaz, Shaw, Siddharth,
Yes, sir.
Siddharth, Siddharth, better? Okay, fine. Now, if I want to plot, say for example, pressure versus volume, suppose I want to plot pressure versus volume. Suppose I call this as pressure and I call this as volume, then the curve is going to look like this. Experimental observations. That means, say for example, when my pressure was this, I found my volume to be this. So I get this point. Similarly, when the pressure is this, I get the volume to this. So this is a second point. So when I basically decrease the pressure, the volume increases to this. So this is my volume. So in this way, I basically get this particular kind of curve. So pressure versus volume curve is like this. How did I get it? Experimental observation. Right. Now I'm going to actually give you some more problems regarding these graphs. But before that, just to give you a brief idea about the Charles law, because we'll be requiring this while I give you some certain graphs to draw. Now, basically, let's talk about the Boyle-Charles law. I'm just going to give you a brief description because in details, we need to actually discuss it in the next class, because out here, the concept of absolute temperature comes out. Then absolute temperature scale comes out. Then the absolute idea about Charles law so that you can actually draw the diagrams. Okay. So what does actually Charles law says? Charles law essentially says that volume is proportional to temperature when pressure and number of moles are constant. What does it mean? It means if I increase the temperature, my volume is also going to increase. If I decrease the temperature, the volume is also going to decrease. That means if temperature is increased, then volume will also increase. If temperature is decreased, volume will also going to decrease. But out here, it was opposite. Out here, what it was saying? It was saying that if I increase the volume, my pressure is going to decrease. Similarly, if I decrease the volume, my pressure is going to increase, provided, of course, these two conditions are met. Similarly, out here, this particular thing is going to be true when these two conditions are met. That means what I can write down out here, I can simply write down out here is V is equal to K into T. Just because out here it was proportional. Now, right now I'm writing equal to. So it has to be K into T. That means I can write V by T is equal to constant. Now, suppose I have like this. Suppose I have got two containers. I have got two containers out here. This is my one container. In this container, suppose the temperature out here is T1 and my volume is, say, for example, V1. Now, what I'm going to do is this. I am going to essentially increase the temperature of this particular gaseous system. That means I'm going to increase the temperature. That means what I'm doing out here, I'm increasing the temperature. So if you are going to increase the temperature, the volume is also going to increase. That means out here, the graph is going to, the diagram is going to look like this. That out here, I've increased the temperature, means this has gone to T2 and this has gone to V2, where T1 is greater than, where T2 is greater than T1. That means I've increased the temperature, so the volume has also increased. So what should be the relationship between these two? The relationship between these two will be V1 by T1 is equal to say for example, when I talk about this one, this particular system, V1 by T1 is equal to constant. For this system, I can write down V2 by T2 is equal to constant. Therefore, I can equate this to and say V1 T1 is equal to V2 by T2. This is what we call as the Charles law. Charles law also have got another expression which we're going to do in the next class. So what we have done today is we have talked about Boyles law and the Charles law. Right. In Boyles law, it is the relationship between pressure and volume, provided the temperature and the number of moles remains constant. In Charles law, it is volume with respect to temperature, provided the pressure and the number of moles to be constant. And I have got two different relationships. P1 V1 is equal to P2 V2 for this one, and V1 by T1 is equal to V2 by T2. Okay. Very good. So with this, I'm going to basically, with this background, what I'm going to do, ask you is this, to draw these curves. I've already done one curve. So there are only 5 curves. So let me draw them one by one. Let me draw one by one. Curve 1. I've drawn one of them. I've already drawn one of them. So I've given you 4 curves. 1, 2, 3, and 4. After you have done with this, what I'm going to do is this. I'm going to complicate at least 2 of these curves. I'll complicate this curve and this curve. The first curve I've already given you, experimental observation. How does the curve looks like? The curve looks like this. So I'm going to go like this. The first curve I've already drawn. So the curve will be like this. Right. Can you draw this remaining 3 curves? PV versus P. I'll explain. Wait, let's look into this number 2 curve. So what I've done out here for Boyles law, PV is equal to constant. PV is equal to constant. That means the product of pressure and volume is constant. Try to understand this. If I increase the pressure, the volume is going to decrease in an appropriate way so that the product remains constant. Okay. Yes or no? Anjali and Ria and Siddharth? This product is constant. The product of pressure and volume is equal to constant. That means if I increase the pressure, the volume is going to decrease. And the product of the pressure and volume is going to remain constant. Yes or no? Anjali, Ria, Siddharth?
Yes, sir.
Anjali,
Yes, sir.
Siddharth? Your voice is not coming, Siddharth, better. So the curve is going to look like what? It will be a straight line. That means pressure and volume is constant, means with pressure, the product PV is not going to change. So it will be a constant. I'm going to modify these two curves a little bit later. Right. Next comes the third one. Pressure versus 1 by V. That means what I can write down out here is like this. Pressure is inversely proportional to 1 by V. That means pressure is equal to K by 1 by V. Right? Now suppose I write pressure as Y and 1 by V as X. That means this curve is nothing but Y is equal to mx, means straight line with a positive slope. That means the curve is going to look like this. Yes or no? Anjali, Riya, Siddharth? Anjali, Riya, Siddharth? Y is equal to
Yes,
mx,
sir.
better? Riya Shah?
Yes, sir.
Siddharth? Your hands are still on. Siddharth, yes or no? Okay, fine. I think he has got problems. Now, pressure versus density versus P. Can you draw this curve? Density is what? How do you define density? Density is defined as mass by volume. Can you draw this? Nothing. In Boyles' law, what you're keeping constant? In Boyles' law, amount and temperature is constant. Right? If the amount is concerned, how to define amount? You have defined amount as number of moles, as the number of moles. Number of moles means what? Is the mass of the substance of the gas weight. Now, if the amount is constant, the mass of the substance will also remain constant because molecular weight is constant. एक hydrogen का molecular weight is always 2 grams. एक oxygen का molecular weight is always 32 grams. So molecular weight is constant, amount is constant, so mass of the substance also has to be constant. Yes or no? Riya Shah, Siddharth, Anjali?
Yes, sir.
Anjali? Yes or no?
Yes, sir.
Right. Now let's look. Now, say for example, I know now let's look into this particular derivation. Now what we know? We know that pressure density is equal to mass by volume. That means if the mass remains same, density is inversely proportional to volume? Yes or no? Yes or no? Priya?
Yes, sir.
Anjali?
Yes, sir.
So density will be inversely proportional to volume. Now, once again, we know from Boyle's law, volume is inversely proportional to pressure. हाँ कि ना? Pressure is inversely proportional to volume, or volume is inversely proportional to pressure? Same thing. That means out here density is inversely proportional to volume, and from Boyle's law volume is inversely proportional to pressure. That means, can I not simply write it down out here like this, that density is proportional to pressure? ये दोनों को कंबाइन करके लिख पाएंगे क्या? नहीं लिख पाएंगे. 1 and 2. Density is inversely proportional to volume. Again, volume is inversely proportional to pressure. That means density has to be proportional to pressure. Yes or no? Clearly, Ria?
Yes, sir.
अंजलि बता पहले, बॉयल्स लॉ क्या बोलता है? Pressure is inversely proportional to 1 by volume. Yes or no, Anjali?
Yes,
Ria?
sir.
Ria? Yes or no? Ria Shaw?
Yes, sir.
Is this correct from Boyle's law?
Yes, sir.
Now, density is equal to mass by volume. Now, in this particular Boyle's law, what is the thing? Essentially, you have kept temperature and N fixed. Yes or no? Ria Shaw,
Yes,
Anjali,
sir.
Siddharth? So N means what? N means what? N is number of moles. And how do you find out the number of moles? Mass divided by molecular weight. Yes or no? Ria Shaw, Siddharth?
Yes, sir.
Right. Now, since N is constant and the molecular weight of a is also constant, therefore mass is also constant. Yes or no? For constant N, mass has to be constant. Because molecular weight of gases do not change. Yes or no? Ria, Siddharth?
Yes, sir.
Fine. So, mera mass has to be constant. So this one is constant. Therefore, can I not simply write down that density is inversely proportional to 1 by volume? Can I write this or no? Can I write this or no?
Yes, sir.
So density is inversely proportional to volume, right? And I know pressure is inversely proportional to volume. Now from this, now combine this one and this. Suppose combine this. ये दोनों जब combine करेंगे मुझे क्या मिलेंगे? Density, pressure is inversely proportional to 1 by V, and volume is inversely proportional to density. That means can I not write, therefore pressure is proportional to density? Can I write this or not, Riya Shaw?
Yes, sir.
That means density ko we represent by rho. Therefore, can I not simply write down that P is proportional to rho, or P by rho is equal to constant? P is proportional to rho means what? P proportional to rho means P is equal to K into rho, where K is the proportionality constant. Therefore, P by rho is equal to K. Yes or no, Riya Shaw?
Yes, sir.
So P by rho is equal to constant. Right. Now, what was the curve given to you? P by rho or D, whatever it is, P by rho. ठीक है, चलो rho करते हैं. P by rho is equal to P. So this is constant. How much pressure? If you increase the pressure, density also increases. If you increase the pressure, density also increases because P is proportional to rho. Because P is proportional to rho, if you increase the pressure, the density also increases. Same story out here. That means P by D is equal to constant. That means, will I not get a curve like this? Yes or no? Riya Shah? Yes or no? Riya? Can you hear me, Riya? अंजलि, समझ में कुछ आया?
हाँ सर सर वो थोड़ा दिखा दीजिए ना सर, हम डिस्कनेक्ट हो गए थे, वो जो इसके बाद वाला
Yes,
पेज।
sir.
समझ में आ गया रिया?
हाँ
Yes, sir.
सिद्धार्थ, yes or no? All you need to do is to find out the relationship between pressure and density. We have seen pressure is directly proportional to density. That means P by density is equal to constant. P by density is equal to constant. Whatever pressure you change, that means what I can write down out here is pressure by density is constant. I can simply write down out here pressure by density is equal to constant. That means if I increase the pressure, the density is also going to increase in such a way that this becomes a constant. That means increasing pressure will not change this ratio. It's not going to change this ratio. That's how you get a straight line. Parallel to pressure. एग्जाम में ग्राफ बहुत देते रहते हैं इस चैप्टर से. इस चैप्टर का तो बॉयल्स लॉ, चार्ल्स लॉ में तो ग्राफ इज वन ऑफ द मोस्ट इंपॉर्टेंट थिंग. Clear? Riya Shaw, Anjali, Siddharth?
Yes, sir.
Anjali beta? Anjali? Now, I like to ask you, Anjali, तो सुनने में आ रहा है कि नहीं आ रहा है? Now draw this curve. This is my fourth curve. This is T1, this is T2, this is T3. My question goes like this, जो आप लोग करके आएंगे next day. Relationship between T1, T2, and T3. Similarly, there's another curve out here. This is T1 and T2. Relationship between T1 and T2. ये दोनों करके आना होमवर्क. चार्ल्स लॉ लगाना ये दोनों में. जब टेम्परेचर कर रहे हैं चार्ल्स लॉ लगाना. चार्ल्स लॉ बॉयल्स लॉ एक साथ में लगाना. ठीक है. So any questions Riya today?
No, sir.
Siddharth, any question better? Anjali, any questions? Anjali? Anjali, can you hear me?
Yes, sir.
कोई क्वेश्चन है बेटा? हेलो हेलो.
सर आवाज जा रहा है.
हाँ
हेलो
बताओ.
सर.
बोलो कोई क्वेश्चन है बेटा?
सर आवाज नहीं जा रहा था तब, पता नहीं क्यों.
अभी आ रहा है तो आवाज?
हाँ सर, आ रहा है आपका आवाज. सर आपका आवाज पहले थोड़ा कट कट के आ रहा था.
आप एनी क्वेश्चंस बेटा?
नो सर.
So we meet on Tuesday. चलो bye.
Bye, sir.
थैंक यू सर. बाय सर.